We were talking about factoring by difference of squares, and we want to recognize number relationships to produce equivalent expressions. To start with, it says factor the following expression completely. As we look at this right off the bat, we notice that we only have two terms here, and they're joined by subtraction. Two terms joined by subtraction. That's different than what we've seen before in the quadratic form, where there have been three terms. So if we're looking at our factoring steps here, the first thing we always want to look for, we still want to look for any greatest common factor that we can take out. Then we want to make sure that the a value is positive, or the lead coefficient, so we can factor out a negative if we want to make the a value positive. And then we want to count the terms. So if there's two terms, there's two things that we could be thinking: difference of squares or difference or sum of cubes. But we're not going to talk about cubes. So we should think difference of squares. So the difference part means subtraction here. And then we have two perfect squares. So when we get this, we're going to try to take the square root of both terms to see if it is indeed a perfect square. And then if there's three terms, then we are going to be in the quadratic form, and we either want to use sum and product, guess and check, or box next method. So we'll look at a couple example problems here. First step, remember, we're looking for the greatest common factor. And in this case, we see that we have a 4 and a 16. So I think 4 can come out of both of these. So I'm going to divide a 4 out. And we'll put the 4 out front. And what's going to be left? 4 divided by 4 is 1. So that's just going to be x squared. We'll bring down the minus sign. And 16 divided by 4 is 4. So we factored out the greatest common factor. The next thing we need to look at is, are these two terms perfect squares? We know they're joined by subtraction, so that works, but are these two terms perfect squares? So what we want to do is we just want to say, what is the square root of x squared? Well, the square root of x squared, the radical cancels the square, and so we're just left with x. So that one is a perfect square. The next one we want to check is we want to check 4. Take the square root of 4. The square root of 4 is 2. So both of these are perfect squares, so we can continue forward with our difference of squares. So we have the 4 that we still need to keep because we factored that out originally. So we have the 4 factored out. And then we're going to make a binomial here, or two binomials multiplied together. All right. Now, what we're going to do is we take our two square terms and we substitute them into the binomial here. So x is going to be the first term of both binomials, and 2 is going to be the last term of both binomials. And the way that we're going to join these is we're going to join these by opposite signs, or these in here. So we're going to have minus the first one and plus the second one. And what that does is makes it a conjugate pair. And so a conjugate pairs, in this case, we're talking about x minus 2 and x plus 2. Okay, conjugate pair. That is going to be two binomials joined by multiplication. All right, two binomials joined by multiplication. We have x minus 2 and x plus 2. And the operation in the middle is multiplication. The first and last terms are the same. So in this case, our first term for both was x, and our last term for both was 2. So they both have the same first, and they both have the same last terms. And then opposite sign between the terms. So those are the things that are going to make up a conjugate pair in this case. We need to have two binomials multiplied together, joined by multiplication, and then we have the first terms are the same, the last terms are the same, and then the thing that makes it the conjugate pair is that they have opposite signs that join the two terms. Look at one more example. So we have 20x squared minus 245, and I don't know 100%, but, well, yeah, I do know 100%. This term ends in a 5. This term ends in a 0. So I do know that I can divide 5 out of both of these. So if we divide 5 out of both of these, the 5 is going to stay out front of the parenthesis. 20 divided by 5 ends up being 4. And we can't divide the x, so that remains x squared. Bring down the minus sign. And 245 divided by 5 is 49. And again, we have to check to see we do have two terms joined by subtraction. So that's the difference. And now the squares part, we got to check to see if these are perfect squares. So what I'm going to do is I'm just going to take the square root of 4x squared. The square root of 4 is 2, and the square root of x squared is x. So that one works. And then we can check the square root of 49. And the square root of 49 is 7. So that works. If you're not sure, you can always use your calculator to check to see if those are perfect squares. So we're going to write down the 5 here. And we know that we're going to come up with our binomial because we're going to make a conjugate pair. We can also know that we're going to have opposite signs. It doesn't matter if you say plus here and minus here. They just have to be opposite. And then the first terms are the same, so 2x and 2x. And the last terms are the same, 7 and 7. And the interesting thing about conjugate pairs, if we go ahead and FOIL this backwards, the middle term ends up dropping out. So if we won't go to check this, we can say 2x times 2x is 4x squared. And 2x times positive 7 is 14x. And then right here, if we say negative 7 times 2x, that is negative 14x. And negative 7 times positive 7 is plus or minus 49. So right here, we have a plus 14x and a minus 14x. Those two terms drop out, they cancel each other out. And so we're back to 5 times 4x squared minus 49.